Hello everyone, I'm Paul and today we're solving problem 135, candy. This one is hard, but there's a simple trick that we can use here to make this easier. So keep watching for the intuition, approach and efficient solution. We're given an array ratings, which represents the rating value given to each of n children standing in a line. And we need to give candies to the children. Here are the requirements. Each child must have at least one candy, and children with higher rating get more candies than their neighbors. And our job here is to return the minimum number of candies that we need to give to these children. So let's say we have this array. We know that each child must have at least one candy, so we can start giving one candy to each of these. So this gets one, this one gets another, and this one gets another candy. And children with higher rating should get more candies than their neighbors. 2 has 2 neighbors, 1 and 2. 2 is equal to 2 and 2 is bigger than 1. So in this case, we should give one more candy to this than the candies we give to this. So here we will give 2 candies. And 1 plus 2 plus 1 is 4. So the minimum amount of candies that we need to give to these children is 4. This is what we return. Now let's see another example and how can we solve this. Let's say this is ratings, and remember that each time we are checking the neighbors for the current value. So let's say that we are here at 29, we are checking 51. If we are here in the last value, we are checking 72. But if we are somewhere in the middle, let's say we're here, we're checking 87 and 72. So let's see what happens when we try to solve this in a single for loop. Let's say we start here, the I pointer is here, and we start with one candy for each of these. And given that 51 is bigger than 29, we add one candy here, so this is now 2. We update the I pointer. Given that 87 is greater than 51, we give one more candy than 2 to this one, so this is now 3. Now we are here and 87 equals 87, but 87 is greater than 72. So we could think about giving 2 candies to this one and update I. Now this is smaller than this, but it's greater than this, so we could give 1 plus 1 candies to this one. So this is now 2 and we update I. And now this is smaller than this, so we keep 1 candy here. But we have a problem here, because look here. 87 is greater than 72, but we have 2 candies for 87 and 2 candies for 72. We should have given 3 candies here to 87. And this is because we were trying to solve this in only one for loop and checking both neighbors each time. So here comes the trick. The trick is that we will check first the neighbors in the left in one loop, and then we will check the neighbors in the right in another loop. This is the whole trick. So now let's apply this here. Now we are starting at index 1 and we are giving 1 candy to each of these. And now we are only checking neighbors in the left. So from 51 we are checking if 29 is smaller. And in this case it is smaller, so we are giving 1 plus 1 candies to this child. So this now gets 2 candies and we update I. Now 87 is greater than 51, so we give 2 plus 1 candies to this child. So this now gets 3 candies and we update I. Now 87 equals 87, so we keep 1 candy and we continue. 72 is smaller than 87, so we update I once again. And 12 is smaller than 72, so we end here. Now this is the candies array up to this moment, and now we will iterate this from right to left. So I will be initially here at index n-2. And from here, we are only checking neighbors in the right this time. So 72 is greater than 12, so we give 1 plus 1 candies to this. Now 87 is greater than 72, so we give 2 plus 1 candies to this child, so this one gets 3 candies now. Now 87 equals 87, so we keep the 3 candies and we update I. Now 51 is more than 87, so we update I again. Finally 29 is more than 51, so we end here. This is our final array, and now we need to sum these values, and the result is 12. So this is almost the entire approach, but we are missing one important part. So let's see another example. Let's say we have these ratings, we give 1 candy to each child initially. Now we iterate this from left to right from index 1, and we are checking every time if the current value is greater than the previous value. So this will be the array after the first iteration. And now we need to iterate this from right to left. And we start here at index n-2, and 5 is greater than 2. So we should take 1 plus 1 and replace the candies for this child with 1 plus 1. But here comes the problem, we have a 4 here. So we have more candies than 1 plus 1. So if we replace this 4 with 1 plus 1, we will be breaking the requirements. So in this case, we want to keep the 4. What this means is that in the second loop from right to left, we will keep the maximum between the current value and the neighbor value plus 1. So after the second loop, when we go from right to left, we will get this final candies array. So the result will be 11 in this case. Time complexity for this approach will be big O of n, because we are doing 2 loops on this array, and this means that we will require n plus n time complexity, and this is overall n time complexity. And space complexity will also be big O of n because of this candies array. So now let's go with the code, and hopefully you will get the idea. First, n equals length of ratings. The result, this is the candies array, so we will start with 1 for each child times n, and finally we'll return the sum of this candies array. And here in between we will do our 2 for loops. So first from left to right for I in range from 1 up to n. If ratings at I is greater than ratings at I minus 1, result at I equals result at I minus 1 plus 1. And now for the second for loop, we are going from right to left. So for I in range from n minus 2 up to minus 1, and in steps of minus 1, this means we are going in reverse. If ratings at I is greater than ratings at I plus 1, result at I equals to the maximum. Remember, this is very important. From result at I and result at I plus 1 plus 1. This is result. So this is it for the code, and now let's submit this and see if it works. As you can see, this works and it's efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.